In this example, it is saying that a force F is applied tangential at the topmost point of a sphere of mass m and radius r. And it is saying if the ground is rough enough to prevent sliding, we are required to find the linear acceleration of a sphere. Let's first draw the situation like say if this is the rough ground on which we have placed a spherical object, on which at the topmost point we have applied a tangential force F. In this situation, this is of radius r and it is of mass m. As the ground is rough, say it will exert a friction in backward direction, and due to the combined effect of force and friction, say it will accelerate with an acceleration a. And obviously due to the torque, it will also roll with an angular acceleration alpha. And we can write for pure rolling of body, as it is given that the ground is rough enough to prevent sliding, we can write for pure rolling alpha is equals to a by r. On this situation, if we write equation of motions, we can say for linear motion it is F minus small f is equals to ma, and for rotational motion we can write the torque is Fr plus Fr. I've added the two torque because force as well as friction both will provide clockwise torque onto the body, which is equals to I alpha, and the moment of inertia of sphere is 2 by 5 mr square, and angular acceleration for pure rolling can be written as a by r. Here this r gets cancelled out, and if we add the two equations, say this first and this second equation, on adding this friction gets cancelled out, it is 2f is equals to ma plus 2 by 5 ma will be 7 by 5 ma. On solving we get acceleration as 10f by 7m. That will be the answer to our problem. Here, as we have calculated the acceleration, using this we can easily find out the friction also. So if we analyze the friction acting on the body, as we know in pure rolling the friction is static friction. So here we can see the value of friction as F minus ma. If we substitute the value of acceleration, you can see this F minus 10F by 7. Here friction is minus 3F by 7. And this negative sign shows that the direction is opposite to what we have already considered. The friction magnitude is 3F by 7, but it is coming negative. That means actually we have taken direction backward for analysis, but it is acting in forward direction. We can also analyze the same question by taking friction in forward direction and still will get the same result. So result will never be affected even if by mistake you have taken a wrong direction. After analysis you will get the actual direction in which the friction is actually acting. Now for the same problem we can go for an alternative solution. Say in this situation on the sphere, as it is given that at the topmost point the tangential force F is acting. And in the way we have handled the problem, we have taken the direction of friction in backward direction, because as we know, if the body is in pure rolling, at the bottommost point of contact no kinetic friction is acting, it is only static friction. So we know well that static friction, as the bottom surface is at rest, will not be doing any work and won't affect the kinetic energy of the object. So unlike to the previous case, say we'll handle the situation by using the direction of friction taken in forward direction. In this situation, say if the body is accelerating with an acceleration a and having angular acceleration alpha, so for pure rolling alpha can be written as a by r, and in this situation obviously the ground will experience friction in backward direction. For the body of mass m, we can write equation of motion for body. So for translational motion we can state, we'll write F plus small f is equals to ma, and for rotational motion we can see that the external forces is applying a clockwise torque on the body and friction is exerting an anti-clockwise torque. So we can write Fr minus Fr is equals to I alpha. For a sphere, the moment of inertia is 2 by 5 mr square. The angular acceleration can be written as A by R. In this situation, this R gets cancelled out, and if we add the two equations, you can see this will give us 2F is equals to 7 by 5 ma. So here we'll get acceleration as 10F by 7m. So this will be the answer to the problem, which you can see exactly the same. If we just evaluate the friction in this situation, then by this equation 1, we can use F plus small f is equals to ma, and I can write acceleration as 10F by 7m. So here m gets cancelled out, and the friction I'm getting is 10 by 7F minus F. So here the friction I'm getting is 3F by 7. Whereas in the previous situation we have seen that the friction was negative, which was an indication that the friction was acting in forward direction. Now if I have handled the same solution by taking friction in forward direction, I can say the result must be positive, which I am getting. So here you can write down a note or as a hint for solving problems of pure rolling on a rough surface, that in cases of pure rolling in a problem, solution will not be affected by direction of friction on body. Be careful in various cases of pure rolling. If you take friction in forward or in backward direction, the result will remain same. It will not be affected. But it is advisable that in general you should take friction in backward direction. Otherwise, it depends on your habit how you feel comfort in the given situation.